Chris Lopez here with Go Engineer, and I'm going to run through the basic setup and operation for applying a two-dimensional toolpath wrapped around a three-dimensional cylinder. So, if you follow along, I'll show you the steps in the process. So first thing we need to do is open up a sketch. Let's open one up on this right plane over here. See if we can normal to this right plane. There we go. Okay. So first thing I'm doing here is I'm creating the diameter for the cylinder which we will wrap the features around. Call it a 6-inch cylinder. And we'll come back over here and extrude this as a boss. Say 12 inches long. There we go. So, new part. Need to add a few things here before we can start putting some toolpath on. Very first thing we need to do is get a reference plane that's tangent with this upper surface here. So our first reference is going to be the top plane, and we'll make a parallel mate. And our second reference is this outer diameter, so here we have our sketch plane tangent with the perimeter of the part. Make it a little easier to see there. Right now I'm just changing the color of this face. Okay. So, what we need to do now is on our new sketch plane, we'll go ahead and open up a sketch. And I'm a big fan of starting out sketches with center lines. We'll go ahead and make a horizontal center line that intersects the origin. Now we can start drafting our features and contours. So I'll make a quick little box here and give it some dimensional information. So 3 inches wide and let's say 2 inches tall. And we'll go ahead and fill it all the corners with a 0.250 radius. So what I'm doing here is I'm modeling what would be the hypothetical top edge of the rotary cutter. So what I'm going to do here next is actually, what I want to do is select all this geometry that we've created, and I want to create an offset of about 0.010 of an inch. That would be the theoretical flat on the blade that you then go ahead and that you guys would sharpen by hand after hardening. So we'll go ahead and exit the sketch. Oops. Let's do that one more time. So offset that entity 0.010 of an inch. Hit the green mark. Select chain. Offset. That's what I wanted to do. Turn the base construction off. So now we have two profiles. So now we need to exit the sketch and create this wrapped feature. Using the wrap command over here on the feature tree, now it's asking which sketch do I want to wrap. So we went ahead and selected our source, and now we need to select which feature we're wrapping everything to. You can see right there is a nice little marking of the contour that we're going to make. And here is our extrusion size, so it's going to project up from that surface 62 thousandths of an inch. So now we have some features we can start working with. This is enough to generate a toolpath on, but if we wanted a more accurate model with those 15-degree tapers on either side, what we could do here is just add in a chamfer. Let's say it's 0.062 tall and it's 15 degrees high, and we'll go ahead and chamfer this entire edge on the inside. And you can see the projection of what that would look like. This isn't necessary, but it does help and makes the model more flexible later on down the line. So we'll do the same thing by selecting the loop on the outer edge and chamfering the outer side as well. We'll flip the direction of the chamfer. There we go. So now you can see nice 15-degree edge on that. So a few things we can do at this point. I would probably start by patterning all of these features here. We'll make a linear pattern of this wrap, and we'll just populate one entire row. So my wrap is what's being patterned. I want to pattern it along the direction of that edge with a 3.25 spacing in between everything. 3.25. It looks like we get just about 3 instances. And we'll do the same thing and chamfer the inner edges too. So now we have a couple of features that have been populated. We can hide this sketch plane so we don't need to look at it. And we're ready to start putting some toolpath on here. Now we could wrap this around rotationally too, but we can take care of that in CAMWorks. So a few things we need to do before we get started applying some machining here. Very first thing is, since this is a 4th axis feature, we would need to identify a coordinate system here. It just helps give CAMWorks a rotational counting point. And we also would benefit from having a stock sketch here. So I'll go ahead and put a new sketch on this face on the side, select the face and convert the entities to project that edge. And now we'll offset that edge by 0.062. And here we will make the base construction since we only want to use that outer profile. Exit the sketch and give it a name. Call it stock sketch. Okay, so now inside of the CAMWorks menu, we can start applying some parameters here. So I'll get my machine set up by double-clicking on the machine node. And here I can select which machine I'm using, which post-processor I'm selecting. What's important here is on the setup page, this is where you call up what type of indexing you're doing. In this instance, we're doing a 4th axis index, and we want to input our coordinate system here so we can give us a good counting basis. Okay, and the rotary axis is around X. You can see our little arrow here showing which direction the rotation will be. And our stock manager, double click on that, and here we'll select our sketch type, extruded sketch. We'll select our stock sketch and give it a boundary condition. So now we have a nice superimposed cylinder that's perfectly within that sketch boundary. Okay, so now we're ready to start putting some toolpath on here. I'll start by putting a setup in the feature. It doesn't matter which direction it is as long as it's perpendicular to this outer surface. And what we're looking here is to add in a multi-surface feature, or a wrapped feature, I'm sorry. So the first thing we're doing is wrapped pockets. We'll go ahead and select this inner edge on all 3 of these sides. Let's see if I can change the color of this face here. Maybe not at the moment. We'll come back to that. So you can see this little green projection, right? Now we want to say how tall these wrapped features are. We want them to go up to this height, and We can also chamfer the walls while we're here. It's a little difficult to see just because of my poor choice of color. Sorry about that. So this way we're also giving these features the exact criteria that they're all meeting with. So I need to make sure I got all of these features in here. And they're all tapered, so they all look right. Yep. Okay. And I've already programmed a strategy in here, so that way we'll get us a good baseline on some tool information and speed and feed information. Let me go ahead and change the definition here for all the rest of these pockets. So, with this Avis pocket strategy, I have a rough and a semi-finish operation, as well as a custom definition for a 15-degree cutter. So the 15-degree cutter will come around and finish off the taper on the inner wall of this pocket. So by generating the operation plan, I'm invoking the database for any information it has about speed and feed and tool selection and contour information. So you can see our roughing sequences, roughing out the pockets over here. You know, if we wanted to make any changes to what was automatically generated, we can always come in and double click on the setup, the operation right here, and we can make some changes. So let's see, if we want to put a radius on all these edges and link moves. So we'll go ahead and change these. We'll make some round and curved splines here and just give it a little bit of a dimensional value, so when I hit preview we can see the toolpath change and update based on that. So you can change your feeds and speeds and how you enter and exit the contour. All sorts of information can be changed within the operation parameters menu. So at this point we should have a pretty decent toolpath. We'll go ahead and just suppress everything else, the 3 copies down the way, so we can just see what the single toolpath by itself does. So there's our semi-finish and the finished contour mill. So go ahead and simulate what we have in this toolpath. So it's running a little slow just because of all the curves and contours we gave it. You can see it's starting to chug there right on the edges. That's okay. We'll come back in and change things back the way they were just so they simulate a little bit quicker without all those swoopy edges. So we'll just turn the high-speed options off. Recalculates the toolpath. Now let's see what we've got. So it'd be great if we could see chips flying and coolant spraying everywhere. But you get the idea. So we'll turn up the speed a little bit and hustle through this operation. Exciting stuff, I know. And the next operation comes in here with just a quick little semi-finish pass. Just trying to pause it so I can speed it up a little bit. I know that doesn't make a lot of sense, right? There we go. Just making a quick little contour pass on this tool path right here. And then here comes that nice little engraver tool. Looks familiar, right? So I've custom defined this tool previously inside of CAMWorks. It's just as easy as creating a revolve section and inserting that into the database. So after a quick little run to see what the results of this toolpath will be, we'll check the show difference comparison here, where it shows where any faces may have been overcut or undercut. Here it's overcutting just based on the direction of the toolpath, so we could always come back in and change that around, but it's a quick little comparison, shows you how things progress and work down the line. So what else can we do here? I'll add in the outer perimeter here just as easily. So we'll add a new wrapped feature, but instead of a wrapped pocket, we need to add a wrapped boss. And we'll select the outer bottom edge of the part. You can hardly see a little green projection on there. Sorry about the bad color choice. And same thing here. I'll set the in condition by selecting the top face of the part. I could also just set a blind extrusion, and got a little bit of a angle on this wall. There we go. And I've also saved a strategy using that 15mm tool here as well. So generating the operation plan, and then generating the tool path. Will get us to some familiar places. So we got the tool path on the outside, a rough and a finish. We'll go ahead and simulate everything that we have here now. Just go full speed to the end, since we've seen this all before. Still finishing off the inside. And next we'll see a toolpath on the outer perimeter. And there we are. So, what's left at this point? This is essentially good G-code, but then we just have to populate it along the rest of the assembly. We don't necessarily have to program every single individual feature and contour. We could just as easily make a pattern. So same thing as we did inside of Solidworks, we could do a linear pattern, we could do a circular pattern around the outer perimeter here. You can see a couple of green bosses here, and let's go ahead and pack that in. We'll say we want 6 instances. Yeah, that looks good. So after I've defined the feature for just one of these contours, we can populate it along the rest of the group as well. So if I show you the rough mill operation here, just by adding that pattern operation, it's gone ahead and populated across every other setup, every other face where we demanded a pattern. And this, at this point, is ready to get sent out to your machine. So we can post-process G-code, check it line by line if we want, or we'll just fast forward to the end and see where that gets us. And bam, we're ready to go to the machine, start to finish, programming some G-code. But wait, there's more. So you said you do a lot of programs in a day. You probably don't want to do that over and over and over every single day. What's nice is, now that we've had it set up, now that we're still inside of the CAMWorks, SolidWorks flexible dynamic work environment, we can just make a small change to this sketch. Let's say we want this pocket to be 3 inches wide as well. Let's change the orientation here. So we like a 3-inch tall pocket, and we'll go 2.25 for the height. So now that we've dramatically changed that, let's see how Solidworks handles the information, as well as CAMWorks. So, the idea with CAMWorks being feature-based and model-based is that when the feature itself changes, the toolpath will also change. So you never have problems with the wrong toolpath on the wrong part. As soon as I come back over to the CAMWorks operation tree, it's going to tell me, hey, something has changed about your part. Let's go ahead and give it a light rebuild here. And this will recalculate the toolpath for the new features just based on the new bounds of the contours that we gave it. So now that I've programmed everything successfully for one contour, we can see where we're at with everything else. So we can see it's regenerated the toolpath for my individual little feature here. And that was just a quick model change, and we have 2 separate toolpaths. So that's the gist of it, programming wrapped features only using simple 2D sketches. Hope you enjoyed it. Thanks.